Getting a little clearer on thermodynamics and kinetics. First and foremost, to know that a reaction is thermodynamically favorable means that it is associated with a decrease in Gibbs energy. Don't get confused, the total energy of the universe is a constant and does not apparently change. Gibbs energy of a system is related to the entropy of the universe. A reaction system is characterized by the difference in the Gibbs energy of the reactants and the products. This is the change in Gibbs energy, or delta G. The change in Gibbs energy associated with a reaction, delta G, typically involves changes in both interaction energies and entropic factors for the system, rather than the universe as a whole. Changes in interaction energies, known as enthalpic changes or delta H, correspond to whether the system has released energy into the universe, exothermic, or absorbed energy from the universe, endothermic. A negative delta G of a reaction system corresponds to an increase in the energy of the universe, which means that the process is thermodynamically favorable, as expected from the second law of thermodynamics. It is common to see the formula delta G equals delta H minus T delta S, which deals with the system, not the universe. When we talk about an entropy-driven reaction, like membrane formation or major aspects of protein folding, it means that the change in entropy in the system, delta S, that occurs during the reaction is positive. Even reactions in which delta H is positive can be favorable if the delta S is large enough. Remember, delta G equals delta H minus T delta S. We can think about every reaction system in terms of energy and reaction pathway. There is an energy of the reactants and an energy of the products. The difference between these, the energy of the products minus the energy of the reactants, equals the delta G of the system. If delta G is negative, the reaction is thermodynamically favorable. But whether a reaction occurs depends on the reaction pathway and other factors like temperature and the presence of catalysts. Here's a reaction pathway that connects reactants and products. We can look at this reaction pathway and think of it as a series of reactions. The delta G of the limiting step for this reaction pathway is unfavorable. This reaction will occur if there is enough energy available through collisions with surrounding molecules, thermal motion, or the absorption of light. So knowing that a reaction's delta G is less than zero, or negative, does not tell us whether the reaction will occur in a particular situation, or if it does occur, how quickly it will reach equilibrium. In many chemistry courses, a reaction is termed spontaneous if it is thermodynamically favorable, that is, if delta G is less than zero. I've always found this to be confusing language. In standard English, spontaneous implies something that is in fact happening. Because of this, we consistently distinguish between whether a reaction is thermodynamically favorable, delta G less than zero, and how fast it occurs, that is, its reaction rate. It is important to note that if a reaction is at equilibrium, it must be occurring at a rate greater than zero.